Hello, hello. Let me, so I'm doing this for a reason. I think we have stream chat read only. Okay, I'm doing this for a reason. I'm starting early because I need to make sure that things are actually how they should be. Okay, got that one, got this one. I think we're gonna be good. Okay, nice. All right, so I'm trying something a little bit different today. For anyone that's watching, you might notice things look weird. And that's because, let me just, all right, okay, cool. I just want to make sure the sound settings. Okay, so I tried out, as this channel's growing, I want to see how I can try to get the word out there a little bit more, to try and help more people, to try and help myself, to try and get more into this space. So I am trying out Streamlabs today for the first time, and I wanted to start a little bit earlier. Generally here in like a starting soon screen, I don't imagine that people generally talk, but I just wanted to see what it sounded like. I just wanted to make sure things were working as they should be, which it looks like they are. And based on what I see on YouTube, it's looking good. Based on what I see, let's see. Based on what I see on Twitch, it's looking good. Let me also open up the Twitch one just to make sure. Okay. So again, for anyone that's watching this for the first time, I'm trying out Streamlabs. I'm trying to see how to integrate everything into multi-streaming. It's sort of, I'm very new to all this. Back when I first started, I started, I don't know, 3 weeks ago. My first goal was to hit 50 subscribers so I can get myself a microphone. And, I sort of suffer from this thing where I feel like, oh, I need better gear, or I need better services to be able to get sort of, to be able to accomplish my goal. But I realized that at the end of the day, you got to do the thing, which in this case, the thing is I got to do LeetCode, right? That's what people care about. So again, just having some filler here, trying to see how this all works out. It seems good so far. I'm happy with how things are going. And let me refresh. Oh, I guess, does this show if I refresh? Okay. So yeah, it looks like everything's good right now. So I'm just gonna go ahead and stop talking for a little bit, and we'll start at 12:30. I just really wanted to have this down. That way it sounds fine. And if people respond on chat, if they talk on chat, then we can also, I'll go ahead and answer you there. But I'll stop talking for now. You know what, I think since we're already here, we don't actually need to start at the time that I'm scheduled for. I mean, we have 2 minutes. I think it's probably good for us to go ahead and get started. So I'm hoping, let me see, I need to add, if I do live here, okay, I think, yeah, that all looks good to me. Let me again make sure, you might hear me going back and forth a little bit. Again, it's just really for me to make sure that everything looks as it should, which I think it is right now. So yeah, without further ado, let's go ahead and get started here. So what is the weekly roundup? I think people on Twitch might be seeing this as LeetCode accountability stream, but let me give you all a quick sort of idea of what this all is, and then we can go from there. So about 2 weeks ago, I started doing daily streams of me doing LeetCode because I just think it's good for me to practice. It's good for me to be able to talk out my ideas, and it's also hopefully beneficial for the viewers. Now, I realize that there are plenty of amazing resources out there to learn LeetCode, and honestly, I highly recommend that you view all of them. Your study plan should revolve around visiting multiple sources daily to be able to get just sort of a better understanding of what's out there and what different places can offer you. Now, one thing I noticed, however, is, these videos, while they show you how to do a question, they sort of already go at it by, like, by the time you watch the video, they've already solved it. So they're just giving you the answer, which, depending on your timeline, if you have like a month to interview, that can be extremely beneficial. So again, that's why I recommend doing those. I sort of wanted to do something a little bit differently. I enjoy talking to people. It's sort of, I'm just a people person. So I figured, hey, let me start just streaming myself doing these LeetCode questions, and hopefully that, that can help people. And that's what I started about 2 weeks ago. And I started from the easiest question on LeetCode. My goal is to do every single LeetCode question and hopefully grow the channel to do more LeetCode stuff. And then maybe even other programming related stuff. But I need to focus on a niche, right? And that niche right now is LeetCode. So what did I do? I started, like, if we go here to algorithms, we go on acceptance. I just clicked on all the easy ones by acceptance, and I started doing all the questions, like from question 0. That's why I say it's really dependent on your timeline, right? If you have time to be able to do everything, or rather, if you have time to do everything, you can watch the stream. If you want a shorter timeline, you view the other resources. But this was sort of my way to make it fun and hopefully interesting for people watching this. So started doing all of them, and I've been streaming daily. If you have been watching with me since the beginning, we'd be sitting at 135 questions right now, which I think is pretty good. I'm very happy about that because, I don't think I've ever done this amount of questions. And even though they're all easy, I promise you there's a lot of value in doing easy questions if you do the right ones. And speaking about that, I also have even a list that I created. I have like Rafael Negron's list. I'm not trying to be a competitor with like NeetCode or LeetCode 75, but this is just another list that you can use of problems that I think are high quality questions. They're not grouped in any particular way, but they're all questions that I think are good to do and will teach you something new. So what is the weekly roundup now that we got all the way around that? So the weekly roundup is every single week I go back and I do questions that we either didn't finish, maybe the like to dislike ratio was just out of whack, so it wasn't really good, and I just try to fill in the holes. So if we scroll down here, right, we'll see that, okay, we did all these questions, all these questions, all these questions, all these questions. That's awesome. We're probably going to get to like, okay, here, minimum time visiting all points. This is the first question we haven't done. So ideally, I want to get all check marks, right? So that's what the weekly roundup is for, just to go back and sort of fill in the gaps and see if we can't actually complete every single question. Now, when I was looking at this last time, this specific question, I guess now we'll actually start doing the leet coding. When I was looking at this question last time, it seems pretty complicated to me. But since I have since sort of looked at some of the hints, I don't think it's going to save which one of these I went down on. But I was sort of looking at the hints because initially I thought maybe I can use like a breadth first search and do something with like shortest path. But I thought, man, this is like first page of easy. But what ends up happening, right? Like the first time a question is published, and this might be a new question only because if you look at, well, I guess the like to dislike, maybe it might be a little bit older, but the first time a question is published, it's like all over the place, right? It's trying to find its niche. So this might be a medium question, sort of masqueraded as an easy one right now, but turns out, I guess many people think it's easy. So I'm just gonna try and like go for it and see what we can learn. And I know I keep saying this, but I will be going back and forth just to check on like just to check on the stream to make sure everything's like looking good. So, okay, let's see. So minimum time to visit all points. So we're essentially given this plane, right? This 2D plane, and we want to be able to go through each one of these points in the shortest time possible, or the minimum amount of steps needed to be able to do that. Pretty much what the hint said, and I think we can figure this out. We need to figure out like what direction we need to go in. So like 1, 1 to 3, 4. You can imagine like here we can go, it's telling us that we can go up 1, or we can go 1 to the right, or we can do, what is it, the square root of 2. Right, so we can do square root of 2 times this way and keep doing that. So if you think about it, like it seems like maybe the best way to go, or the minimum time, is I think by going up and right, we're sort of doing 2 moves at once, right? Because we can go up 1 and right 1, or we can just go diagonal. So really what the hint was saying is continue going diagonal as many times as you can, or continue going diagonally in some direction until you get to like the line, right? And the line in this case is represented by what, like x, right? Like x is going to tell us what line we're on. So if we're starting at 1, 1, let's say we're starting at 1, 1 here, and we want to be able to go to 3, 4. If we're moving diagonally, like we can figure this part out first, then we need to figure out like how or what direction to go, right? But if we go to 2, 2, we can still keep going, and then we can go to 3, 3. Now, if we go to another one like 4, 4, is that okay? Let's see, 3. We want 3 to be our x, right? So we need to be in the same column. So we say, okay, 3, 3, 4, and 3, 3 are the same column. So now we just need to go up 1 to get to our y. So that's how we figure out that piece. And then really to go from 3, 4 to negative 1, 1, now we can do the same thing again. So we want to go from 3, 4. We want to go from 3, 4, and we want to go to, what is it, negative 1, 0. So let's see if the same theory works. So we can keep going diagonally as we can keep going diagonally until we get to the column that we're looking for. So we go from 3, 4 to 2, 3 to 1, 2 to 0, 1, and then to negative 1, 0. And it actually turns out in this point, we're at the same column and we're at the same y. So we don't need to do anything. So I think that's a pretty good way right there of trying to solve this question. So now we need to figure out like how, or like in what direction do we need to go, all right? And how can we determine this? Like at any given point, we're gonna go right. We're gonna go right if x is greater than our current x, and we're gonna go left if the next x is less than our current x. So go left if you can say like destination of x is less than current x. Right if destination x is greater than current x. And then what do we do for our y, right? We go up, pretty much the same thing. We go up if it's greater. So let's say we go up if destination y is greater than current y, and down if destination y is greater or less than current y. So now using this, let's see how we can sort of like try and formulate an algorithm here. So we're gonna have to go through all these different points, right? And let's also see if we do this, if we actually do like square root of 2, right? Move diagonally square root of 2 units. In other words, move 1 unit vertically, then 1 unit horizontally in 1 second. And I know this might be like a very simple thing to answer, right? But like square root of 4 is 2 because 2 times 2. So what is like square root of 2 is going to be some decimal, right? Math dot square root of 2 is 1.41. So how do we just round down to get 1, or are we doing 1.4? So like why is it 7 seconds at the end? Because are we doing like we go 1 up here, we go 1 up here. So let's do 1.41 times 2. That's going to be 2.82. Then we go up 1, right? So that's just going to be 3.82. And now we go 1, 2, 3, 4. So 1.41 times 4, 5.64 plus 3.82. That's actually 9.45. So that doesn't sound to me like the most obvious way of doing this. Can't just go up 1, then we go here, and now we just keep going, keep going, keep going, keep going. Am I missing something though? Oh, wait a second. I think here it's up 1, up 1. This gives us to 3. No, that's 3, 3. Then we go 3, 4. Right? And then we just keep going down. So why does that not work there? 1.41 times 2 plus a 1. Right? And then we do 1, 2, 3, 4. We're doing the same thing that way. 5.64 plus 9.45. One optimal path. So I think I'm maybe like getting this. Move diagonally square root 2 units. In other words, move 1 unit vertically, then 1 unit horizontally in 1 second. So is that still... So is it still like 1, 1? It's like 1, 2, 3, 4, 5, 6, 7. Okay. Yeah, I don't know why I was like trying to do some like weird math like that. But let's try to figure out source to destination. Okay. So we have all this sort of stuff right now here. Let's now get to this next piece here. So in our points, what is it that I want to do? I want to go, I'm going to just make some space for ourselves here. We want to really start, let's say min steps is equal to 0. We want to say for let point equal to 0, point less than points dot length minus 1, point plus plus. Now the reason I'm doing points dot length minus 1 is because I want to stop the loop here, right? Because stopping before the last one will allow me to get my destination, and that's how I can figure it out. So let's see. I can probably, I would like to make different functions that could allow for me to go in whatever direction I want. But let's see. Let's say const coordinate 1 is equal to points at point. And then const coordinate 2 is equal to points at point plus 1. All right, so now we have the source and the destination. Now, if I want to move up, down, left, or right, that's the piece I have to figure out. So maybe I can start just writing out the code altogether. Like I'll start writing out the code and then we can optimize at the end. Because normally if I try to optimize in the beginning, I just get to this point where I'm just like making a mess of things. So let me see if I can find out the direction that I want to go in. So if coordinate 2 of 0 is less, let's see, so the current, so the destination, maybe I should make this coordinate 1, I should say current, and I should say destination, right? That's going to make it a lot easier here. So if destination of x is less than current of x, which is current of 0, right? We want to move left. Else if destination of x is greater than current of x, we want to move right. Else if destination, let's see, if destination, this is not x, this should be 0. This part should be 0 here. If destination, what do we have here? So if destination of 1 is greater than current of 1, we want to go up, so move up. Else if destination of 1 is less than current of 1, we want to move down. Okay, so we'll have our loop that continues doing this. Now how can we, it'd be nice if like pass these points that appear later in the order, because if we have 3, 2, and 2, 2, I need to pick a direction and just move up. I need to pick a direction and continue moving in that direction until I get to the column, right? Because in any one of these directions, it's always going to be the column that I have to match on. So yeah, this makes it a little bit weird. Because I'll need, maybe I should always do, like, let's say this piece is going to be what helps me go in the diagonal direction. And then I'll have some other piece that helps me either go up or down. Something like this. That's what I'm thinking. So if we want to move left, let me try to figure out the easy case, right? While here we can say while move right. So can I just change, can we just change the, yeah, I guess I can just do, let's see, min steps if I want to move right. So I want to keep moving right until x is less than, or while x, yeah, we can say like while current of 0, which will be 1, 1, is less than destination of 0. We can say current of 0 plus or equals 1, and here we can say min steps plus or equals 1. Right, so what would this do? Let's sort of like just stop right here and think about what it is that we're doing. I see a lot of room here for like abstraction, but since this question is kind of strange, for me at least, I think this is just the way I want to approach it first. So we're at 1, 1. We want to get to 3, 4. So here, I know that my destination 3 is greater than my current of 0. Sunny Doobie, yo man, keep going. I am loving it. Oh, Sunny, that's so awesome to like. Thank you so much for writing the comment. I really appreciate the support. Yeah, like again, like my intent with this stream is not necessarily to teach people LeetCode because I realize there's a lot of really great resources for that. It's more of like you watch someone do LeetCode questions and see how they approach it because I feel like you can get a lot of value from that too. So yeah, keep the comments coming. You know, if you have your own ideas or like even if you've solved the question before, like I'd love to know. And if you even want to talk about like your own LeetCode journey, I'm down for that. I'm probably going to keep this stream going for a while today. Normally I try to do it like an hour, but I might do 2 hours today because I'm trying something new with Streamlabs and I'm having a lot of fun with it. So yeah, I really appreciate the support, Sonny. Hope to see you around. Cool. So while current 0 is less than destination 0, current of 0 plus or equals 1, right? So now we'll say current of 0 plus or equals 1. So this will become 2, 1. Okay, we'll do it again. We'll make it 3, 4. Well, right now I'll be, okay, yeah, it's just this. But I probably should do the same for both, right? Current 0 plus or equals 1. And I also want to move it in that direction. Current of y plus or equals 1. So I'll move both of them. And then at some point we're going to break because now it's 3. So at the moment we get to either up or down, we can decide, how do I now know if I want to go up or down? If, yeah, it seems like a lot of like very specific code I'm writing here, but I'm sure once we get to the end, we'll figure out a better way of abstracting all this. So here we can say if, let's see, if current of y is less than destination of y, right? That means we're going to go up, else that means we're going to go down. So what do we do here? We can now say current, or you know what? Maybe we don't even need, I mean, I suppose I can just have 2 other while loops here because will it ever be, yeah, let me do that instead. I'll just create like a while. Let me just remove this one. While current of 1, so here we're at 3, 3. I need to go up 1. While current of 1 is less than the destination, which is 3, 4, we should do current of 1 plus or equals to 1, min steps plus or equals to 1. Something like this. So this gives us to there. MMD, hi. Hello. Hey MMD, really glad to have you around. That's awesome. Yeah, let me know if you are all, I'm very curious to know like where you all coming from because I'm trying this like multi-stream thing out. From what I know, and let me just check the stats here. Like some of you all may be coming from YouTube and others might be coming from Twitch because I also have like a Twitch stream coming up. So yeah, I'd be curious to know like where you all coming from. Okay, so min steps plus or equals 1 while current is less, min steps plus or equals, okay, that's fine. And now let's also take care of the down direction. While current of 1 is greater than destination of 1, here we'll do current minus equal 1 min steps plus or equals 1. Nice. Yeah, welcome from YouTube. Glad to see you around. Okay, so this is super specific code. I'm not in love with this, and I'm definitely not advocating for your code to look like this because you can imagine now I have to do essentially the same thing for each one of these. I think at some point though, like for any one of these, I'm always gonna have to go down or up after moving in the diagonal direction at some point. So because of that, I almost feel like I can move this out here, right? So what's my thinking here? The reason I moved this to the end, and now this whole thing is like, what happened to my ending curly braces all the way down there? The reason I move this to the end is because, like I said, I'm going to first figure out how to go left in some diagonal direction, and then I'll figure out how to go up or down once I get to the same column. So that's what I'm trying to figure out here. So let me like remove all this stuff now that I have a better understanding of this, and let's just go over. Remember, this is a code for a very contrived example, but I just want to sort of do it in my head. So min steps is 0. For let point equals 0, point less than points dot length minus 1, point plus plus. So we get our current with points of point, which will be 0. And then we do our destination. So we get points at point plus 1. So that will give us the 3, 4. So if destination of 0, if 1, yeah, I should say if, and you know what? I feel like this will read better if I flip the condition here. Like I want to go, let me see the left. Like the left would mean that current, if I'm going to go left, it means my current is greater than the destination, right? So if current of 0 is greater than destination of 0, that means I go left. If current of 0 is less than destination of 0, that means I go right. And actually, do I even care about, do I care about this right here? Because wouldn't this, so if x is, because it can be in that way or that way, so how do I know what direction to move in? So do I have to do like a double condition here? I got your channel recommended by YouTube algorithm, and man, let me tell you, I have been doing code forces for 2 months or so, and I want to start my LeetCode journey. Hopefully you will continue these streams. Oh my God, that's so cool. It's super cool to see that this is, I'm glad this is being recommended to you on the YouTube algorithm. That makes me feel awesome. Like it makes me feel like this is actually being propagated to other people. So I really do appreciate that. And yeah, like just for a 30-second tangent real quick, I've been doing these streams every single day since July 16th. So I'm not stopping anytime soon. Like every single day I've been doing a stream. For example, if you go to like this playlist right here, LeetCode Live Easy Collection, you can start from the first stream I ever did, and when I had 0 questions done. And if you just, like I did this because if you think about it, this makes studying very easy, right? You just open the playlist and you follow along. And there's 2 ways that I imagine people will like approach this. Let me just like pause this here. 2 ways that people I think will approach this, right? Like here, what I did was I have the video. Now this is one of my first videos. I don't have the mic I have today, so it's gonna sound, the audio is not gonna be as good. But you can do the questions and then watch the stream, or you can watch the stream while doing questions. And what I do for each stream is I have chapters that you can use for easy navigation, and then I also have the questions that we cover, so you can just like link out to LeetCode very easily. So yeah, I'm not gonna be stopping anytime soon because it's also helping me a lot too, right? So I definitely want to continue the practice. All right, cool. So let's get back to this one, because this one I think just got a little trickier maybe. Do I need to figure out, how do I know, like if I'm going, like why would I go up here? I would go up because the x is less, but then not only that, right? Like why, if destination 1, I guess I probably still do need these 2. If destination of y, because could it be, x could be less than the destination, but it doesn't necessarily mean that I'm going up, right? I might also have to go down. Yeah, that's when it becomes like a little bit, that makes it a little bit more difficult there. Let me think about this. How do I, like my concern with this question is I'm trying to simulate it exactly. It's like I'm trying to build like a game, and that seems too specific right now. But let's write out our directions here, and let's figure out how we can maybe go about doing this, because I think maybe that will help me. So I have, yeah, that just seems way too specific. Like if x is less, if x of 0 is less than y of 0, and x of y is less than y of 1, that means go up, right, right? And similarly, but if x1 is great, right, this will be the same thing, and x1 is greater than y1, then that means we go down, right. Now, how do I know if I want to go up left? I go up left if x0 is greater than y0, and x of 1 is less than y1, right? Yeah, that will mean, this will mean up left. Oh, Minaj, Thank you for joining again. That's awesome. Yeah, okay, so the first thing I thought of doing was the first thing I wanted to do was like the distance formula. I thought maybe I can just calculate like the distance between this one, and then the distance between this one and this one, but it turns out that's not the answer. I was really hoping that would be, but yeah, it might be some mathy trick, which I know some people don't like that in LeetCode, that you have to kind of like be good at math maybe, but let's see. So x of 0 greater than y0 and x of 1 less than y1 up left. And now to go the other way, it would be that x of 0 is still greater, but x of 1, maybe this shouldn't be x of 1. This is going to be greater, right? Greater than y1. So we always have less than, greater than. So I can sort of, let me break this down a little bit here. So if the current, I'm going to sort of write this if condition again. My thing is, how is this an easy rank? Exactly, yeah. I don't think, my thing is, probably what happened is this is a newish question and it hasn't found its spot yet. Like the more people do it, since it's all community driven, it'll figure out where it belongs on its own. So current of 0 is less than destination. If it's less than destination of 0, that's going to be like one condition. Else if current of 0 is greater than destination of 0. These will be my x's, right? That will be my x's, and now I can figure out if current of y is less than destination of y. That will be one thing. Else here, we can do the same thing now. If current of y is greater than destination of 1, that will be a different thing. So I think this covers, because it's either going to be that it's going to be in here or in here or in here. I think this might work. I'd use some diagonals. Yeah, like I'm wondering, well, that's the piece that I'm failing to discover. Like, how do I use the diagonals? I'll be honest, like I did a cursory look on the solution, and I saw some people drawing triangles. So it very well could be that. And I think even the related topics we can look at, it says geometry here. So like math and geometry, two mathy things outweigh the more data structure thing. So it could be that, right? So if the current, if x, does this cover all directions? If the x is less than this, okay, or the x is less, it'll be less, it'll be greater if it's either in this direction, and then we can decide to go, yeah, so I think this covers all my different ways here. Like here will be if current of 0 is less than destination, and the current y is less than destination 1, this will be my upright, else here we should have our downright, right? Yeah, downright. Here, if current 0 is greater than destination and current 1 is greater than destination, I'll make this less. This will be up left, and this will be down left. Okay, now I feel like I have a better sort of like conditional structure here, right? So let's maybe just focus now on going in the diagonal. So if current 0 is less than, why would you draw? Oh wait, I just heard a noise. Oh, I guess that's just to show you how new I am to this. I just got a noise from Twitch and I'm like, what is this? So yeah, thank you. It's like AI Piggybot. I'm not sure if that's a real person. Maybe it's a real person. I hope it's a real person. But that just goes to show how new I am to all this. I heard that noise and I'm like lost. Like, what is this noise? That's pretty cool. That's awesome. Okay, let's get back to the stream here. Minaj, you can find the resultant force. Okay, so let's see. If we know, then we're going to go in some direction. And maybe here, it'd be nice if I can just draw, or if I can, Yeah, I guess I'll have to do this every time. So like if I want to go an upright, maybe here we don't even have to say, maybe here again I can just do my while loops. Maybe here I can just say while current of 1 is less than destination 1, we'll like remove this else. And then here we can say while current, if I want to go down right, then the current of 1 will be while it's greater than destination of 1. I think we can maybe do this. Right? If I want to go upright, I have to do current of 0 plus or equals 1, current of 1 plus or equals 1, min steps plus or equals 1. Can we just do that? Now we do like sort of the same thing here. If I'm just going down, we subtract both, right? Yeah, because this is like from 1 to 1, this is going to be 2, 2. From 1, 1 to, let's see, if I'm going from 1, 1 to 0, 2, 0, 2, what I'd have to do is I subtract 1 from there and increase 1. Or no, wait, that's not, no, it's going to be, right? Wait, am I doing this? X will be, no, X will be 2. Yeah, what am I talking about? X will be 2. If I'm starting from 1, 1, if I'm going from 1, 1 to 2, X will be 2 and Y will be 0. I don't know what I was thinking there. So here we'll still keep plus or equals 1 for the X and minus equal 1 for the Y. Okay, so let's say we have that. And I want to keep my direction here. Okay, so while current, and then maybe we can do the same thing in here. So let me actually just do while this. Let me delete my else here. Let me take this out. Now I can say while, so if I want to go up left, if I want to go down left, here we can say while the current Y is greater than destination of Y. So now let's figure out this piece. Let's again copy this code in here. If I'm going up left, if we're gonna go from, let's do this, right? We're going from 1, 1. From 1, 1, we'll be landing in 1, 1. This will be Y at 2, X at 0, X at 0, Y of 2. So the X is gonna go minus equal 1 and the Y will go plus or equal 1. And then if we want to go down left, we would be going from 1, 1 to 0, 0. Right, so both, now we're subtracting both. Minus equal 1. Okay. So let's like go through this because this seems like crazy here. Move left, so I don't need this one anymore. Right? So let's see if this handles, let's try and go through this whole thing now. So let's say, again, we have current is, and I'll just write this out. So current will be 1, 1 to start, and destination will be 3, 3, 4. Yeah, no, like, so Minaj, like, I did skip this earlier, like many streams back, but the point of today's stream, which I like to call the weekly roundup, is so that we could go back and revisit all the questions that we haven't done. Because ideally, like on any given page, I want to have all of these marked off. So like this one is the first one that I hadn't done, so I just really want to revisit it. But yeah, I definitely skipped it. I think I skipped it twice actually, but I think today is the day. Like this is the furthest I've gone, so I'm just gonna try this out. Oh, nice. Yeah, thanks for being here, man. Yeah, every Saturday I do the weekly roundup. Okay, so 1, 1 to 3, 4. So if the current 0, right? So if 1 is less than destination 0, which it is, that means I want to go up right. Or no, now we got to figure out the next one. While current of 1 is less than destination of 1, we can start adding these, right? So current at 0, we're going to add 1 to both of these. So this becomes 2, 2. Let's put our min steps up here. Min now equals 1 after this first loop. Then we go again. While current 1 is less than destination of 1, right? 2 is still less than 4. Oh, but see, I think I'm already getting to this will be 3, 3. Yeah, this should actually be, we should keep going until we get to the same column. So this should be if current 0 is less than destination 0. Now, how do we know? So if current is less, and then do we also have to figure out while current of 1 is less than destination of 1? Okay, now do we also have to do an and? While current 1, because I need to go until I get to the same column, but I can't just check for the column. Like, how do I know to even do this? Maybe what I do is I just say if current of 0 equals destination of 0, right? Perhaps we just break. So let's start over again and see where we were. So we were at 0, right? When we first started, current of 0, 1 is less than 3. So we increment both of these, 2 and 2, and min step is 1. 0 or 2 is not equal to 3, so we keep going. Current 1, 2 is still less than 3, so we again do 3 and 3. We increment 2, and now current 0 equals the column, so we break out of this loop. Now we get to the next one. While current of 1, right, because that would just take us here. Do we need to go down, right? So if current of 1, if y is greater than, which is not, so that's fine. Now we just break out of here, and we can figure out where to go. So if current of 1, which is 3, if current of 3 is less than destination of 1, we increment current of 1, and we do min steps plus or 1. All right, so now we get to 3, 4 min steps, right? This breaks because now current 1 is no longer less than. Current 1 is not greater than, so we just now go to the beginning. So let's say, oh, I wasn't counting my min steps all the way, but let's say 1, 2, 3. Let's say that's going to give us 3. All right, so now we're at 3, 4. So now let's see if my logic here holds true. Now that we're at 3, 4, I want to go to what? Negative 1, 0, right? That would have taken me all the way. Let current equals points of point. Oh yeah, then this thing would have, okay, this thing would have broken. I would have started the new loop, right? Now I'm at current 3, 4, and I want to go to negative 1, 0. Okay, this is like, I think this is going to be the really where we figure things out. So is current 0, is 3 less than negative 1? No, it's not. So current of 0, 3 is greater than negative 1. Okay, cool. Now if current of 1, if 4 is less than 0, no. 4 is greater, so we're going to subtract 1 from 0 and add 1. Right, so we're going to be doing 2, 5. See, so that doesn't work, right? Here we have to do, we're going from, what I want to go from 3, 4 to 2, 3. So down left should be subtracting from both. And we should kind of see a pattern here, right? Plus, 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 minus, minus, plus, minus, minus. I think that's good when we see that pattern. So now we do it again, right? We do min steps plus 1. We got to the 4, and now we're at a 2, 3. While 3 is greater than the destination 1, yep, we do the same thing. So 1, 2, min steps 5. All right. Now we go again. While current 1 is greater than destination 1, 2 is greater than 0, we do the same thing. So 0, 1, that gives us 6. 1 is still greater than 0, so we do negative 1, 0, 7. Right? We end this because now current, well, let's see. We end this loop, right? Which I think I probably should. I need to be checking the columns here every single time. Not something I'm particularly in love with here. I think this is always going to be, I can probably put this in the while loop, but for now, this is just checking my columns. Okay. I broke out of this thing. Now, are any of these true? Is 1 less than destination 1? Right, so 0, nope, it's not. Is 1 greater than? No, it's not. So it comes out here, it finishes the loop, and we just return min steps. I mean, honestly, I'd be stunned if this was right, because it's such a contrived like question, or the code is very precise, which is like, if you've all been doing software for a while, like when there's code that looks so specific like this, it scares me, because I'm thinking like there's got to be some abstraction I can get here. Let me just do I really want to do 3-2 for fun, or you know what? Let's just run the code. Let's just run it for this one example and see what we get. Are we going to get a time limit exceeded? Beautiful. Oh, wait, no, it worked. Okay, so we got 7. It ran for a while. So, like, let me try this again. Maybe it was just LeetCode. Exactly, it's hard-coded. Right, it's very precise. I don't love it, but let's see. Let's see if we get a 5 here. 7 and a 0. Wow. Completely off. 3-2 and -2-2. Can we just like, could we draw? Can we just do a drawing ourselves? Let me see, like 2D graph online. I just want to like I want to put some points. I've never used this before. I have no idea how this works. Okay. What do we want here? 3-2 and -2-2. So 3-2. Oh, can I not put a point? Point. 3-2 and what? -2-2. So the best way would be to do what? If we go 1-1, 2-2. No, this is not. It should be 3-2 down here. Can I delete this? Can I undo? Let's do 3-2 and -2-2. So if we go 1-1 and then we go 2-2 and then we go 3-2, that's 1, 2, 3. And then from 3-2, we're going to go to 2-1. We're going to go to 1, 0. We're going to go to 0, -1. That's definitely, is that 5? Doesn't feel like 5. That definitely feels like more steps for sure. Output 5. So we went up here. We went up here. That's 2. We got up here. So now we got to go down 1. And now we're just going to make a beeline towards like, yeah, this is a tough question. This seems like, hey, it worked for the first example, but why am I getting, I'm not even getting the next one. Let's like run through this ourselves, right? So point equals 0. Okay. So let's say we have 3-2, -2-2. Hard coded. Okay. Hard coding it again, but let's see what we get. We need some print statements. Yeah, we do. We definitely do. When I used to have premium, I was able to do like the debugger, which was super useful. But let's just like go about this way. Let's do it this way. Okay, so 3-2 to -2-2. So if current of 0 is less than destination of 0, which is not, if current of 0 is greater than destination of 0, which it is, right? So we're going to enter this one, right? We want to go, oh, and now we say, okay, so we're in here. Well, current of 1 is less than destination. No. And then we say, what? Oh, is this because I'm not? I guess they can be in the same. Yeah, how do we know 3-2 to -2-2? Oh, do I have to start at the origin? I don't have to start at the origin. I think that's where I messed up here. I don't need to start at the origin. I start at 3-2. So if I go down as much as I can. So which one takes precedence? If I want to go down left or, because if I did, let's see, if current of 0, 3 is greater than -2. Okay, so because of that, I know it's going to be on the left-hand side. Wait, is this? -2, 2. Oh, it's the same. I see. It's the same line. So you know what, actually, it shouldn't even make it here. It should actually go directly here. Oh, so it's not just same line, it's same row. That's what I did not do here. So while current 1 is less than destination 1, diagonal should be default if your current XY val doesn't match the destination value, if that makes sense. Yeah, I need something like that, right? Like a nice default that like always do this thing or do this in the special case. I think what I did here, because current 1, so if 1 is less than destination 1, but here it's not. If they're the same, I have to just keep going in that way. Yeah, so this takes care of, again, we're going to do some hard coding. Not in love with it, but let's see if current of 0 is less than destination of 0, and if current of 0 is greater than destination of 0. So now we have, yeah, if destination of x is greater, then we do this minus equal 1. And if it's less, we do this plus or equal 1. Okay, let's see what this does. Oh, of course. Do you guys know if like do runtime errors count as incorrect? Like does that mess up my acceptance rate? Oh, 7 and 5 and 7 and 5. That makes me happy, but you know what? Like this is taking a while to run. It feels like this is going to be borderline time limit exceeded. But let's see. 7 and 5. Oh man, this is the moment of truth. Can we do it? Submit. Holy moly. Wow, that's crazy. Honestly, I wasn't very confident about this one. There's questions that I'm like, oh, I know this is gonna work. And this one though, yeah, I mean that's cool. Let me see what happens if I run it again. Wow, is it just like fixed on 41.49? It's a mess, but it works, yes. And honestly, I don't want to sound complacent or just be like, oh, like you shouldn't or whatever, but this question's not very related to data structures and algorithms, right? This is more about like traversing a 2D plane. That's what it sounds like to me. I mean, I guess there's some value in knowing how to do this well, but let's see if we can do better though, or at least maybe abstract some of this away to make the code shorter. So while current is less than destination and the current of 0 is not equal to destination of 0. If I condense these, it'd be nice if I can make a function that like plus or equals, plus or minus. That's the thing. Like it's very minus equals minus minus. I wonder, can we do something like, let's see, while current is less than, I don't think that's really gonna help. But we can say maybe like const move in direction. Current x and y. And this, I mean, I don't really think this will help too much, but perhaps what we can do here is we can say move in direction current, and we'll do 1 and 1. Here we can do 1 and -1. Here we can do -1 and 1. And here we can do -1 and -1. could do this. I mean, that really is barely doing, that's not doing much for us, but let me just run the code, see if this gives us the same result. Okay, let me submit it. I'm gonna keep submitting it. I'm gonna try to like, okay, it even got worse. But let's see. Okay, if current, this is all the same for all of these. So it'd be nice because this whole thing right here, I'm not always like min steps. I have to continue going in whichever one of these I do. I mean, I could, it seems weird to also have min steps in here. I like to have functions do a singular thing, and having this also manage min steps seems weird, but let's also put min steps in there. Memory got better, right? Nice. I actually didn't even notice that. Thanks for pointing that out. Oh, that's a new, I don't recognize you. Oh no, maybe Karate. I feel like I've seen you on one of these streams before. Your name sounds familiar. So if I have seen you, welcome again. Thanks for joining. And if I haven't, welcome anyway. And thanks for joining. Cool. Let's see the next thing here. So let point is 0. What else can we do here? This is very, very particular. I mean, we could also have 1 and 1 move in direction, 1 and 0, 0 and 0, current. I might even be able to abstract this completely. 0 are though, no, well, this is less. Yeah, that might be a little bit more complicated. This one, yeah, I'm like hopped in the last weekly roundup. Awesome. Yeah, I know for some people I do these earlier, so I know for some of you on like different time zones, it helps that I do these earlier, because during the work week I normally do the daily streams at a much later time. So I think what I'm gonna do is, just for the sake of the stream, since we've been on the same, yeah, exactly, like I think I could do that. But let's see, it's been 57 minutes. We've been on one question for an hour, so I'm like happy that we at least came back to it. We reasoned about it. We thought about it. I'm not sure how much more value I'll get out of abstracting this. I think what I can do is let's see what discussions have to say, and then we can wrap up this question and move on to another one that maybe it will be more fun. Of course, like, oh, here we go. Okay, let's go to most votes, because I see simple and I'm like, oh, come on. Like, is it really that simple? A 6-liner and a 1-liner. That's awesome. All right, so the time cost to travel between two neighboring points equals the larger value between the absolute values of the difference. Okay, consider points x1, y1, and x2, x2. That the distance is x1 minus x2 and y1 minus y2. According to the constraints of the problem, each step at most moves 1 unit along. Therefore, the minimum time is greater than or equal to the max of dx and dy. 1 unit to combine the above, and we have max is less than, okay, that's traverse the input array for each pair, comparing the absolute difference. My gosh. I mean, this is, man, it's hurting my brain. Genius solution. Yeah, I want to see what someone else put here. What's the greedy approach? We should walk most points diagonally. If we cannot make a move, then these points should be covered either horizontally or vertically. 5 and 3, we would walk 3 diagonally, and remaining 2 have to be walked horizontally. So the answer is the max of the absolute values of I1 minus I minus 1, 0. I would have to like really draw this out for me to understand this. I can't, I mean, easy peasy lemon squeezy. Point to point 2, take the greater change from x1 and x2. Add this to your running total. Rinse and repeat. Winning. Why? Going diagonally lets it move twice. Going horizontal or vertical lets it move once. Diagonal is twice as fast. Okay, that makes sense. Prioritize diagonal movement until any of these happen. Then you move horizontal or vertical. The change is always going to be the greatest difference in either x's or y's. So if we come back here, so there's a 2 here and there's a 4 here. So we move 3, and then we just take the difference of the x or y's. Is that what they're, no, wait. And we just add that going diagonal, let's move twice. Example. Points pop, math abs, x2 minus, this is weird. I sort of, okay, I get the diagonal piece. Seeing one-liners after spending an hour on the problem makes me sad. Yeah, it does, but we also don't know how they got there, right? That's like one of those things where, that's why I think a stream like this hopefully helps, because we don't really know, like all these people that are posting these questions. I mean, who's to say that this person just didn't pretty much copy the number one guy's answer and then just like kind of reformatted it in their own way? Like it could have also taken them an hour, and then after a lot of analysis they were able to like get it down to something better. So I'm not very concerned, honestly. Like I'm just happy that we came back to it. We succeeded at doing our weekly roundup piece, so I think that's cool. Give me 1 second. I'm just gonna get a quick cup of water, and I'll be right back. Let me see if this there should be like a Streamlabs thing I can do here for like an intermission, I guess, or be right back. Let me see if that works. That'd be cool. I'll see you guys in like less than a minute. All right, so yeah, it seems like that worked. That's pretty awesome. Like it's it's pretty cool to see this, because now I joined the stream game late, but now being sort of like in control of it and doing like the little cutaways and things, it's pretty neat. I like it a lot. That's awesome. So yeah, like let's just keep it going here. Finally, we can move on from that question. We don't have to worry about that anymore. Let's get to another one. Now, as you can imagine, weekly roundups are generally going to be slower in the sense that we'll probably cover less questions. If I skip the question, it either means that the like to dislike ratio was so bad that it wasn't really worth my time at that moment, or it was just like too tricky and I couldn't figure it out. So you can imagine that these are going to take longer. So let me just go through all this again and make sure. So all these are checked. Checked. Cool. Just did this one. So wait, does that mean we did everything on page 1? Oh, we did everything on page 1. Nice. Yeah, give your guys give yourselves a pat on the back if you followed me from day 1 or day 0, because if you have, that means that like if you've been with me since day 0, then you are also done with page 1. So nice. We can go to page 2. That's very cool. Just imagine when we're starting to do medium questions. That's going to be like a whole other thing. That's going to be awesome. So, all right. So a number after a double reversal. This is my little unofficial mascot, that cat down there. By the way, that cat comes from this extension I'm using for like LeetCode Dark. is it this one here? Yeah, LeetCode Night is the extension that I'm using in case you guys want to know. So let me remove all this code I had before and let's read it again and figure it out. So reversing an integer means to reverse all its digits. For example, reversing 2021 gives 1202, and reversing 12300 gives 321, as the leading zeros are not retained. Yeah, so what I wanted to do is let's like write the first one down, right? 2021. How can we start to like reverse this? So I'm sure you guys know the trick of being able to pick off individual digits. If not, it's a very good trick to know, and I'll be showing it here on the stream so you guys can also learn it if not. So if you think about it, like we want to make this what, 1202? Yeah, 1202. So we want this new thing to be like the 1000th place, I guess. But how do we add, like if I did 1 times 1 plus 2 times 10 plus 0 times 100. See, I don't think that's gonna work. And then 2 times 1000. That's gonna give me 2000 and what, 21? Reversing 21 gives me, that's just gonna give me the same thing again. It's not gonna give me 1202. So like my thing trying to figure out was like, how do I get my 1 to be the 1000th place? Like, how do I know where to start? How do I know what my multiplier is? That's the thing that I was trying to figure out the first time. Because it's easy to multiply, right? Like it's easy to get the numbers to be in reverse order, but how do I add it up so it actually becomes this? Because I want that 1000 to be, I mean, we could maybe put it like in a stack, I guess. But do I want to create like new storage every single time? I mean, so let's imagine we did that, right? And we did 2021. I can push that one. I push that one. I push that one. I push that one. And now what? Starting from here, well, that would still be my 1000th place. So really, what I want to do, so would I just like pop? Would I pop off this one and do 2 times 0, or 2 times 1 plus 1? Oh yeah, I guess we can do 2 times 1 plus 0 times 10 plus 2 times 100 plus 1 times 1000, right? So I'll give me 12. It won't give me 12. No, yeah, 1202. Yeah, 1202. Yeah, no, that'll give me 1202. Oh, I think I just hit the mic, so sorry if you guys heard that really loud. How would solve it in Python? Convert it to a string and loop over it, building it backwards and skipping over 0. Yeah, I guess we can also convert it to a string, right? That's definitely something that we can do, because I can just reverse it immediately there. Maybe we can try it both ways. I kind of want to try this out and see, because I hadn't actually done this one before. So let's make a new function called, let's make a new function called build digit. And this takes a num. And this will do something like const digit stack. Now we can say while, let me just make sure I get this all right. So while num, right, while num is not equal to 0. Now I'll figure out the leading stuff here in a second, right? That's gonna change a little bit how I do things, but I'll get to that in a moment. So while num not equal to 0, we can say const digit is going to be equal modulo 10. We'll do digit stack dot push, or maybe digits. Let's just make this digits, since it's not really, I'm not doing it like a stack. Digits stack, or digits dot push digit, and then we could say num is equal to math dot floor of num divided by 10. And here we can return digits, right? So that'll give me an array of these digits. Now what I can do is I can start, we can also say const, let's see, get digit sum, or calculate digit sum. calculate digit sum, we'll take in digits. Let's do let sum equals 0, let multiplier equals 1. Here we can say for let I equals digits dot length minus 1, I greater than or equal to 0, I minus minus, right? And we can say sum plus or equals digits of I times multiplier, and then multiplier times equals 10. And then we return the sum. So let's see, build digit. So let's see what we get here. So built digit will be build digits passing the num. And now I'll just do like a console log of calculate digit sum of built digit. I just want to make sure this is coming out the right way. So hopefully we'll get, let me actually make a test case be, or we can do both, right? Let's do 2021. I just want to see what it prints out in this instance here. All right, build digits num. What happened here? Build digit is build digits num. Oh, build digit. Okay. Let's make this build digits. Sure. So 625 and 1202. Okay, cool. So that's good. That's good so far. So we know that these two functions work, right? So reversing an integer means to reverse all the digits. Now we got to take care of the, like what happens if we have 1800, right? We can iterate new num as long as there's a digit that we don't need, worry about length of that number. New num equals new num times 10 plus digit as long as there's a digit. That way we don't need to worry about the length of the number. Oh, that's interesting. Wait, so let me just read this again. We can iterate new num equals new num times 10 plus digit. Yeah, you know what? I think I've seen that before. I don't need to worry about the length. Give me a second, because I do want to try that out. I like that. Because I guess, yeah, at every single point, I think you can check if the last num is 0. You have to return true or false after 2 reversing and only leading 0 are removed. I think you can check if the last num is 0. You have to return true or false after 2 reversing and only leading 0 are removed. So let's see. Let me try to figure out this way first. So what happens if I do 1800 here? If I do 1800, if I ever see a 0, right, we don't want to include that, right? So if while num is not equal to 0, digit is num divided by 10, and maybe I only push the digit if digit is not equal to 0. Maybe here we can push the digit. So let's say here we don't want the 0, but we still get rid of it. We don't want the 0, we still get rid of it. We're going to push the 8. Right, we'll push the 8 and we'll push the 1. So we'll get 81. And we should end up with the same thing, right? So now let's do it for 1800, making sure that works. I just want to make sure I get 81. Okay, 81. So now we just need to reverse, what is it? Number after reversing an integer means, so given an integer, reverse num to get reversed 1, then reverse reversed 1 to get reversed 2. Okay. So reversed 1 is equal to, let's just do calculate digit sum of build digits of num. That's reversed 1. Then reverse reversed 1 to get reversed 2. So const reversed 2 equals same thing here, but this time we're going to do reversed 1. Return true if reversed 2 equals num. And if we say return reversed 2 is equal to num. Let's see what this gives us. True, false, false, true, true. Okay, so we got one wrong, which is the 1800 here, which does not equal num, right? So we reverse 1. We already know this gives us 81. Reversed 1 is 81. then we build digits of reversed 1 to get 18. Reverse 2 is equal to num 1800. So why did we, let's do this. Console log reversed 1. Let's do console log here reverse 2. And I only want to do it for the 1800 case. But I want to get back to both of your suggestions you guys made on the comments. 81 and 18. Wait, no. Which one did I get wrong? Reverse 2 equals num. Okay. False, false. Wait, so which one did I get wrong? Oh, I think the last one. Wait, true. True, false, true. Okay, wait, you guys definitely saw that I got that wrong, right? Why is it? Wait, what? You guys definitely saw that was not right the first time. True, false, true, true. That's crazy. Okay, let's go for it. Let's just submit it. $609,576. So let's see what happens here. So 609,576. Oh, wait a second. Wait a second. I think, okay. Last time is 0. You have to return true or false after 2, reversing and only leading. Yeah, it's only leading 0, right? Yeah, you're right. This is the whole thing. So I think that's the comment that you made. And I'm sorry, when I say you, I just don't know how to pronounce your YouTube username. So apologies for that. But I'm speaking about you. So I think you can check if the last num is 0. So how would I know that this is a leading, let me see if it's 18, if it's 1800, if we do 0, 0, if I do 0, how do I check that? Oh yeah, interesting. We can iterate as long as they're a digit. We don't need to worry about the length of the number. Yeah, how do I handle this piece of it not being a leading? Right, so it says here, leading zeros are not retained. Oh, but in this case, I do have to. So like, why wouldn't this work? So this wouldn't work because by the time I get to that, I would just have 0, right? So if my num's already 0, if num is equal to 0, let's do this again. Let's actually do the 1800. Here I do consider these 1800 reversed. Maybe we don't consider it. We don't consider it. Okay. We add 8 and 1. Now in the other one, the one that I failed on was this one here, right? I pop the 6, I add the 6, I add the 7, I add the 5, I add the 9. Now I get a 0. But when I get a 0, so maybe we only add it if digit is 0 and num is greater than 0, we can add it. Would this work? Because if I'm ever at a point, like if I'm at 1800, I pop it, digit is 0, it's still greater than 0, it's still greater than 0. But if I ever get to like this, pop this, pop this, pop this, these are no longer greater than 0. So that means I can just end it. I think maybe that could work. Let's try it again with this. I'm just gonna enter that. Let's try it out with just like test case. Let's run it. Ooh. If digit is because after the first reverse, if digit is equal to 0 and the num is greater than 0. then we can add it. And now I'm just getting false, false, true, false. It's almost like the complete opposite thing I'm getting here. I think you can check just if at the end 0 is false, else true, because after the first reverse, the leading 0 will be removed. And it will be a different number after the second reverse. Let me try to think about this. So you're saying that I can keep the logic I had before with if digit is not equal to 0. No, but this I'm still gonna have to somehow I'm still gonna have to take care of this case. I only don't want to add a 0 if num. Maybe instead of checking specifically for 0, I can just make sure that if the number is currently greater than 0, we can push the digit. But you're saying at the end, if I have this and then I have 0, 0, 1, 1. Oh, but the thing, the way that I think I get what you're saying, right? Like if this one here is a 0, then this would have become the trailing one. I think that's what you mean. If there's a trailing 0 here, I think you can check if last num is 0. Their first reverse. So are you saying that this is a way to solve it, or is this just like an optimization? Right. 81 and 18 is false. But is it only, I mean, that's like one case, but maybe there's like other numbers that wouldn't be, right? So 1801. But I guess these are like similar numbers. What if is that always the case for like numbers that are like, could we do like, would that always be the case? If I do like 1, 2, 3, 4. Oh, wait a second. I thought I just saw something. That was weird. One, two, three, four. It should work for any case except 0 itself. Oh man, that's pretty good thinking, man. Let me just try this again one more time, because if num is greater than 0, we can push it. Let me see what this gives us. True, false, true, 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 false, true, true. Okay. Let me submit this one. Okay, so that worked, but I want to see your case. So do we just, it should work for any case except 0 itself. So if they're both, I mean, if the numbers are the same, we just return true, right? If num, a double reversal, like 1, 2, 3, 4 will equal 4, 3, 2, 1, and then 1, 2, 3, 4. So if the numbers are the same, so you're saying, and correct me if I'm wrong here, like if, no, well, we need to first check to see if num, well, maybe if num equals 0, yeah. If num equals 0, maybe just return true. If you're saying if the end, if the last number's 0, so if num modulo 10 is equals 0, we return false, else return true. Is this what you mean? False. Like, are you saying that this is just the answer here? Oh, because you know what? Oh my God, that's beautiful if that's the answer, man. And you know what? It probably is. It's probably the answer. That is like, that's beast mode right there. This, my friends, let's go for it. You know what? Let's run the code. True, false, true, true. This is going to be it. Oh my God. What a beautiful answer. What a beautiful answer. This is why we LeetCode, right? And can I actually just do return? So if I just do this, can we actually just do that? Wow. Amazing. Amazing. You just blew my mind. Now, how does that run so slow? How is that running? Like, how is it that my solution ran faster, seemingly? That makes absolutely no sense to me. 54.01. It must, I don't know, maybe the code's just executing in a bad server today. Let me see, let me run this again. Very cool, man. Very cool. Okay, I think we just got lucky the first couple of times. Man, you know what? I think I was thinking like I'm only given one num here, and it's only considering one. I think for some reason I was getting like too deep into thinking about reversed one and reversed two. Like in other words, I was thinking about two questions at the same time or two numbers at the same time. But like we don't need to worry about two. We just need to worry about the one and how that's going to be reversed. Like it's always going to necessarily be the same number at the end, right? That's exactly what the question is. That's awesome. That's a very big brain moment. Thank you. I love that. Let's do this one. Remove palindromic subsequences. Our unofficial mascot, the cat down there. Yes, that's super neat. I wish I can like, can I like give you a like or something? I don't know. I don't know if I can do that on Twitch. Let me check. I'm just gonna check some stats here on the right. So I think we're still going on here. Okay, cool. All right, nice. Everything looks good. Everything is as it should be. Okay, so we're given a string s. Let me also remove all this stuff. We're given a string s consisting only of letters a and b. In a single step, you can remove one palindromic subsequence from s. Return the minimum number of steps to make the given string empty. AB, AB, ABB. Okay, so we have to continue moving. So I kind of did this the other day. Yeah, no, but that's the cool thing. Like, hopefully now I understand. Like, I'm replying to you, Minaj. Hopefully now I get it. Like next time, it'll be easier. Or like I'll remember that modulo trick and be like, oh man, I think we can like use that. So that's really where it's at. Okay, so S is already a palindrome, so its entirety can be removed in a single step. Minimum number of steps to make the given string empty. So we did a question like this, I think, yesterday where we had to remove adjacent strings from the string until we got to an empty string. And I'm wondering if like I should only, let me think about this. A, B, B, remove palindromes, A, then B. Like if I'm given an array, if I had an array of this, like A, B, A, B, A. I just want to find a palindrome and remove it. Ideally, I would find the longest palindrome and remove that one. So how, I mean, but then again, this, I probably don't need to find, I don't need to worry so much about finding the longest palindrome. Like, can we just assume that doing some, oh, it doesn't even need to be contiguous. Wow. Wait, so you're saying we can do like A, and then remove, okay. Remove palindromic subsequences. Like when I think about this question, how is it that I can build ABB, we remove A, or I can remove BB. Now here, ABABA, I mean, why would I decide just to do the whole thing? If I use 2 pointers here, do I just want to find, do I have to worry about actually like popping things off? BAABA. So these can be the same, but then not necessarily. Okay. What if we had, wait a second, what if I had frequencies here? Let me see. I have 3 A's and I have 2 B's. Does that help in any way? 2 B's and 1 A. they all have to be coming up after each other. So A, B, A. If I'm like iterating over this string, A and then a B and then an A and then another B and then an A. B, A, B, B. Like why would this work? Why would the non-contiguous part is the tough part. But I think what I'm concerned is I'm thinking too specifically about like finding indices and removing them. I think that I can maybe do this in an easier way. I don't think it's so much about actually removing things. Maybe it's just the amount of like maybe the question is just like how many palindromes can we create given the amount of strings that we have or the amount of letters that we have? Maybe that's what the answer is. Like what's the max or what's the best, I guess, palindrome that we can create given the frequency of these characters? We can always pick even. We can pick many evens and then a single odd. So that's 1. If I have 1 A and 2 B's, right? I have 1 A and 2 B's here. So here it's like we can create a single palindrome. Oh, but they're also, the thing is these are not contiguous. Or I'm sorry, these are, yeah, they can't be. Yeah, that's rough, man. That's a tough question. Why is it's like very heavily disliked? Not very heavily, but it's still, it's very disliked, even though it is liked a lot. But B A A B B. Could a stack help me in here? What if we had B? I say B. Okay, now I put an A. So like right now at this moment, this is not a palindrome, right? I can add another A. If I add another B, I can't make it a palindrome, but if I add a B here, I can. But like, how do you? Yo, Segoy, what's up, man? Yeah, well, I don't hate all palindrome questions, but this one's just like, this one seems crazy without changing its order. But there's another trick here that I'm not seeing yet. A, B, A, B, A. What else can we do here? Let me just check something real quick. Gotta check my phone for a second. Oh, wow. I almost thought for a second, like maybe, like I said, it would be like, what is the, yeah, it's not just about, because if we had BAB, if this was instead of ABB, right? If this was BAB, then the answer would be 1. That's like the largest we can create, but it's not that one. So instead of figuring out how many palindromes we can create given this frequency, maybe if I just start as, can I just be greedy with it? Like, what's the longest palindrome I can make from where I currently am? Is that like, if we're at BAA, okay, I can make a palindrome with 1. If I see an A, like I can't, but I can keep going and see another A. Again, though, I need to remember that it's contiguous order, because here I might say, oh, I have 2 A's and a B, but I can't make a palindrome out of this. Maybe we just, maybe we can do like a 2-pointer technique. I have an I here, I have a J here. Maybe I can like pop these off, I guess. And it would be here and here. And then maybe I say, well, these are still not in the same. So then it's like, okay, I can't do that one. Well, B. So maybe I go down one here. I pop these off. And now I can say these are the same. And I can just pop this one. And that gives me 2, maybe. Let me see. What happens if it's ABB? I have an I, and a J. I should try to find ones that are the same. So let me increase I. Now I and J are the same. So maybe I can pop these. And then I start the loop over. So maybe I can just delete characters. Maybe what I'm thinking of doing is like, I'm going to try something here. It might be a little brute forcey, but let's see. So let's do let copy. We're going to make a copy of our input string. I can say while copy.length is greater than 0. And they want the, let's see. Let's say let steps equal 0. Now what happens if we just pick while copy.length is greater than 0, let start equal 0, let end equal copy.length minus 1, while start is less than or equal to end. Let's see. So while copy of start is not equal to, which one do I want to pick though? I guess it doesn't really matter which one I pick, right? I can either do while copy of start is not equal to end, and maybe whenever I find one, let me kind of go over the example again here, like BAABB. If I do this and I have my start and my end, let's just call it I and J. Okay, these are the same. So what do I do here? I can slice these. But now I won't know, like I is 0, but J is still equal to copy.length. It's not going to reflect the new change I made. But then here, these are not the same, so I need to make one of them the same. So I can sort of, maybe I can come over here and say, okay, remove that one. Okay, so how would I put this into code here? Does it sort of make sense what I'm trying to do? I feel like I can keep removing things, like as long as these are not equal and the characters are the same, I can remove them. I think that's what I'm thinking. Or you know what I can also do too? I can say something like I can say let removed indices equals an empty array while start is less than or equal to end. I want to make them equal. Okay, while start is less than or equal to end, while copy of start is not equal to copy of end, I can say start plus plus, and then start will equal end. So maybe here I can say removed indices dot push start. Okay, what is that gonna do? And then while, no, that's gonna be the same though. While this is the same, and then what if I had another one? While copy of end is not equal to copy of start, end minus minus. This seems crazy. End minus minus, and then maybe here I can put removed indices push end. And then what if we did, we can also say if start is greater than end, we'll break. Else we'll do start plus plus and end minus minus. So maybe here we say, right, like, imagine here we're looking at removed indices. While start is less than end, which it is, While copy of start not equal to copy of end, they're the same. So let's go ahead and push 0 into this index. These are the same, so we'll push 0, 1, 2, 3, 4 into the index. Now we increment these. So A, and then we get to B. Okay. While copy start is not equal to copy end. So now let's just increment. So now this essentially will go all the way to here. So start at end. Okay, so we'll do start plus plus. We'll get to 0, 1, 2, 3. We'll add 3. We'll break while copy dot end. Do I want to add? Maybe instead here I should make this like a new set. That way I only get what I want here. We can do add. We'll still add the 3. We'll do start plus plus j minus minus. But now it's no longer equal to end. So then can I just now go through my set and remove the different indices? That sounds wild. We can do for const value of removed indices. I think, let me revisit a set in Java. I think it has a method for values, iteration methods. Yeah, set prototype values for const value of removed indices dot values. Can we do copy dot splice at the index, and we'll remove a single element. And this whole thing constitutes a single step. Right, so let's revisit this because this seems crazy. Like here we would have removed what? Let's just go over everything again. I and B. Okay, so while start is less than or equal to end, okay. While copy start is not equal to copy end, they are already equal. So let's go ahead and add 0 to our set. Okay, cool. Same thing here. We add 0, but we stay with the 0. Start is greater than end. We don't break. It's because it's less. So we increment I and decrement j. While copy of start is not equal to end, so we increment I until we get to here, right? Because now they're going to be equal. And we push the start. So it's 0, 1, 2, 3. We're going to try and push 3 again with j. If start is greater than end, we break. Nope. So start plus plus j minus minus. While start is less than or equal to end. So now we break out of this loop. Right now, did I not also, I needed to add 4, right? I don't think I added 4 in there. Now we go through here and we splice these. So now we remove 0, we remove 4 and 3, and now we do the same thing. Right? So we start at I and j. We start at I and j. We add a 0, and then we also add a 1. Right? And then we can just splice 1, increase steps, and then copy will just be equal to an empty array. Seems strange. I'm not in love with this question. Maybe that's why it's downvoted. Seems like a lot. There's some questions that are elegant, some that aren't. Oh wait. I went up on the logic. Yeah, at the same time. It's just tricky and easy at the same time. Here is more logic than code and algorithms. Yeah, output is 3 and expected is 1. Okay. I feel like that should work. Yeah, I feel like that should have worked. Am I not? Copy.splice. Yeah, right? If I do splice, does it not? Oh wait, I'm opening way too much up right here. Let copy equals 1. Let's do 1, 2, 3, 4. 1, 2, 3, or whatever, anything. Copy.splice of 0, and we'll remove 1. And what does copy become? 2. Okay, yeah, so it does remove 1. It should work for that first one. Steps is 0, while copy.length is greater than 0. Copy.splice. removed indices dot add. Let's see that first one. A B A B A. So imagine we're here. We have I and we have J. Well, copy start is not equal to copy end. They are equal, so to our set we add 0. While copy of end is not equal, 0, 1, 2, 3, 4, we add 4 to our set. Oh, is it complaining because I'm not? Yeah, because as this moves, yeah, as we start splicing, the indices removed. So like even if I get to 2 and 3 here, or well, let's figure it out. Let's see. Yeah, it's not going to be able to remove. Maybe I need to like order. Oh, that doesn't sound great. That doesn't sound great. But like we increment this one, we decrement this one. These are both the same, so we add 1, 2, 3, right? And then we go up here. We go down here. They're still fine, so we add 2, right? And now essentially I go over here, I should be able to splice everything, but when I splice 0, I end up here, and now I don't have a fourth thing, right? So that's crazy. I want to and even if I ordered it, if it was like 0, 4, what if yeah, just for fun, I'm gonna try something. I'll explain after I'm done here. I don't think this is the way of doing it, but sort of A, B, A minus B. I'm really not happy with this. I'm gonna do a -1 here, and I'll show you why in a second. And I think it's not gonna like this. This doesn't return for const value of removed indices value dot sort. Let's see, sorted set. Move dot value sort. Let's do this. Sorted array. Sorted indices. Removed indices dot values dot sort A minus B for const value of sorted indices. Does it not? If I go over here and create a set, let's set equals new set. Say 1, 2, 3. Oh. So set, okay, set dot values. Oh, it's a set. Unless we do this. Well, this is why weekly roundups exist, and this is why we come back to previously looked at questions. Okay, so maybe we were a little bit closer here. Is it this value 1 thing that's messing up? So still 3 and 1. Sorted indices. We sort it, but now we're getting more. As long as it's, yeah, this one's weird. This one's tough. This might be one that I'm gonna have to like, I might take some more time to think about this one on my own and even revisit it in the second week, or I guess it'll be our 3rd weekly roundup. Yeah, like for next week we can revisit it. Probably gonna have to table this one again. So let's get to our next one. See if we can maybe do like one more, because yeah, we're approaching the 2-hour mark. Count operations to obtain 0. 1 to required to make, for example, if num5. Otherwise subtract number 1. Yeah, I think this one's a pattern, right? Because the brute force solution, like let operate. I don't know why. I think I probably tabled this one because I wanted to try and figure out the optimal solution, but let's see. In one operation to obtain 0. either num1 or, okay, while num1 not equal to 0 or num2 not equal to 0. Let's see. Or no, one of them. Yeah, while both are not equal to 0. There are only 2 letters next time. Read descriptions once again and think that there are only 2 letters next time. Yeah, no, I definitely will. I'm definitely going to take that. You know what? Let me like copy what you said here and put it back. Let me put it here so I can remember that. I'm just gonna go as far as to say like, yeah, let's do this. That way I just remember that hint next time. Thank you. Thank you. Also appreciate you like giving me hints and not just like saying an answer on the stream, because that's not like, if people are giving out answers on the chat, then no one's really like learning. So I definitely appreciate you taking like a very methodical approach to like how you're delivering your hints. So thank you for that. Okay, so here we go. One operation, if num1 is greater than or equal to num2, subtract num2 from num1, subtract num2, num1 minus equals num2. Otherwise, subtract num1 from num2. 2 minus equals to num1. But of course, as we know, let's see, operations is 0. Return operations here, 3 and 3. We get, let's see what we get here. 3 1 3 1. I mean, this might work, but it's probably gonna be slow. 55.71. There's definitely, it's one of those things of like figuring out a pattern. It might almost be, it could very well be like, I don't know if it's bitwise per se, but let's see if we have 2 and 3, right? 2 and 3. Okay, if num1 is greater than or equal to num2, no. So we keep this one, and we, for num2 minus num1, this becomes 1. If num1 is greater than or equal to num2, then we subtract so num1, okay, so this becomes a 1, and this becomes a 1. If num1 is greater than or equal to num2, we make this a 0, and this becomes a 1, and then we just return the amount of operations. So let's come back to 10. Okay, so these are equal. So, oh yeah, just 1. So I guess if it's equal, maybe that's like a base case. If it's equal, it's just 1. Although, yeah, if num1 is greater, num1, that's 0, and that's 10, so that's fine. So 2 and 3. So let's do like another random, like let's do 12 and 15. If num1 is greater than or equal to num2, num1 minus equals to num2, so this is -3. Now, does it need to be 0 or less than 0? Oh, and then wait. Will num2 always be greater? To make either num1 equals 0. Yeah, because if this was 3 and if this was 15, if num1 is greater than or equal to num2, which is not, num2 minus equals num1, that would make that positive, right? So does that mean that num2 is 5, is num2? However, if num1 is 4 and num2 is 5, after one operation, num1 is 4 and num2 is 1. But it's not necessarily saying that num2 will be greater than. I mean, can we just assume that? If it's greater, we just subtract this one, then we end up with here, this one's greater, so we do this. Right? Because this doesn't make sense. Like, oh no, wait, if num1 is greater than or equal to num2, else num2, oh, okay, I see. Wait a second. num1 is greater than or equal to num2, else num2 minus equal num1. This becomes a 3. That one's bigger, so we subtract 3 from here, leave that alone. If num1 is greater than num1 minus 3, that's 6, 3, and then 3, 3, and then 0, 3. 10, 10, 2, 2, 1, 1, 1. Is this just like how many times? 12. If we have 12 and 15, 2 and 3 with 1 left over, but that's 3. 3 goes into 2. Oh, what did I just do? Okay, wait. If we do 3 modulo 2, that's 1, and then 2 modulo 3, that's 2. So that's not actually going to give us, okay. 15 modulo 12. This is definitely one of those, like, I'm guessing it's another, like, mathy problem. That's probably why I left it on the table. Let's see what the related topics are. Okay, math and simulation. I think we did the simulation, but I know there's, like, a better way of arriving at the answer here. That's cool, though. Like, I think for the stream, since, like, we're almost, we're going to hit the 2-hour mark now in 4 minutes. I think it's, like, good. I think it's good. I did what I wanted to do in terms of, like, the weekly roundup. So, yeah, like, for anyone that's been around since the beginning, are you guys enjoying the live streams? Is this something that you all can benefit from? I hope the Streamlabs stuff is maybe going to make it a little more interactive. I'm going to start figuring out how to maybe put like music or something in there, so that way if you're waiting in like the lobby before it starts, you might be able to listen to some music or something like that. Just something fun to make it a little more interactive, but I've been having a lot of fun with it. Hope you guys are benefiting from it. Let your friends know, let your family know, let your colleagues know, that we're out here doing LeetCode Live. I'm very happy with the success that we've attained so far. I think it's like pretty cool just to see the channel growing. I hope people are benefiting from it, and like I said, I think it'll be neat to continue going along with it and seeing how far we come. So yeah, thanks to everyone that joined today. Really appreciate it. If you like it, make sure you subscribe, ring that notification bell so you can be made aware of new streams as I come out. I might do another one tonight, maybe not. Funny side note, I used to be in love with like Guitar Hero and Rock Band games when I was younger, and I recently ordered the drum set for Rock Band, and I got the kick drum for it literally this morning for the drum set. So I'm probably gonna go play some Rock Band now. I'm very excited for that. So maybe I might come back later, I might not, but at the very least, I will definitely be back tomorrow for just like a normal stream where we continue on from, let's see, we'll start tomorrow at this one, projection area of 3D shapes. That sounds fun. We'll get there when we get there. So yeah, thanks again everyone for joining. Appreciate you all being here. Happy coding, and see you all tomorrow. Later.